let's refresh what we talked about last week with respect to inverse, sine, and cosine and tangent functions. Today I have them written as arc sine of x, but it could have just as easily been written sine to the negative 1 of x. When we're working with arc sine, we're going to be limited to quadrants 1 and quadrant 4. In fact, with sine and with tangent, which again is arc tangent, could just have easily been written as tangent to the negative 1 of x. That's going to be also in quadrants in 1. We're limited to working with values that are within that domain and range. And then in cosine, so that we're dealing with positive values and negative values, the quadrants that we have to use for cosine are 1 and 2, and arc cosine and cosine to the negative 1 of x both mean the same thing. We also made some graphs last week, and I want to go back through these graphs again, especially for a couple people who weren't here. In terms of what points are on this graph, the first point is negative 1, negative pi over 2. And if you think about it, it's what's the sine of negative pi over 2? Well, the sine of negative pi over 2 is negative 1. And by the way, I kind of got ahead of myself because I realized that this graph is y equals arc sine of x, and I didn't label that. But one of the points on here is negative 1 and negative pi over 2. We also have a point at 0, 0. And then our other point on this graph is 1 and positive pi over 2. Again, sine of pi over 2 is 1. And we're dealing with inverse functions here, so we're switching the x and the y. So it doesn't change much here in our next graph. Our next graph is y equals arc cosine, or cosine to the negative 1 of x. The values on this particular graph, as we can see, are negative 1 pi. And here's a point right there, which is 0 pi over 2. And then this one is 1, 0. And since we're dealing with the cosine function, it's the cosine of 0 is 1. So I'm pointing cosine of 0. Well, what's the cosine of 0? It's 1. So we're going backwards again. Normally what we've thought of as the x value is becoming the y, and the y value is the x. And a third function here is arctangent, or tangent to the negative 1 of x. In the tangent graph, we have asymptotes. So we still have asymptotes in the inverse tangent graph. They just happen to be horizontal instead of vertical. And the points that we graphed last week were negative 1, negative pi over 4, 0, 0, and positive 1, positive pi over 4. A couple other things to point out. Specifically on the tangent function here, since we were just talking about it. The range of a tangent function is all real numbers. Negative infinity to infinity. And when we're dealing with inverses, the domain and the range switch. So the domain is going to be all real numbers for our tangent, inverse tangent graph. And then we go from negative pi over 2 to pi over 2. But from negative pi over 2 to pi over 2, those values are not included in the range because that is where we have the asymptotes. So we have no values on there. By the way, I could have put arrows there. But in the other two functions, our domain is -1 to 1, and those values are included. And negative pi over 2 to pi over 2, those values are also included in the sine function. And from 0 to pi for our range of cosine, those values are included. It's the tangent one when we have the asymptotes there, where our values are not included in our range. But basically what we're working with here, that's how we kind of looked at it. We're looking at a specific part of a sine function, or a specific part of a cosine function, or a specific part of a tangent function. We cannot look at the whole value because then our function doesn't have an inverse because it fails the horizontal line test. But again, if you got out your unit circle and you want to look back at that to help you out, what we're looking at here is we're essentially given the answer of the value on the unit circle, and what we have to come up with is we have to come up with the angle. In other words, we could have said on problem number 1 that we're looking at sine of what value equals radical 3 over 2. And the thing on here is we need to watch out for our range. All of our values are going to be between negative pi over 2 and pi over 2 for sine. On your unit circle, the cosine values are the x values, the sine values are the y values. So if we look back at our unit circle, what angle has a value of radical 3 over 2? Pi over 3. And in this case here, the inverse sine of negative radical 2 over 2. Again, for sine, we're only looking in the first and the fourth quadrant, so we need the angle value in the fourth quadrant because it says negative radical 2 over 2. But what angle in the fourth quadrant has a value of negative radical 2 over 2? It's going to be negative pi over 4. You don't want to answer 7 pi over 4, which, yes, technically does mean the same thing, but our range is going from negative pi over 2 to pi over 2. So we need to stay within those limits. Inverse tangent of 0. Well, the inverse tangent of 0 is 0. What angle of tangent has a value of 0? There's a 0. So we continue on, and we have lots of them in our notes today. But once again, this simply is saying tangent, and I probably should write a question mark, tangent of what value equals radical 3 over 3. And tangent also works in quadrants 1 and 4. Quadrant 1 has positive tangent values. Quadrant 4 has negative tangent values. Same situation for sine. So what angle of tangent has a value of radical 3 over 3? 5 over 6. And what value of tangent, what angle value, oh, I can't get this out. What angle in tangent has a value of 1? Now cosine's a little bit different from problem number 6. Cosine, we're finding angles in quadrant 1 or quadrant 2. In this particular case, this is arc cosine of 1. 1 is a positive value, so we should be in quadrant 1. And what angle of cosine has a value of 1? It's actually 0. Easy to get that mixed up sometimes. When we look at number 7, another cosine 1, this time it's the inverse cosine of negative radical 2 over 2. So now we're going to be in quadrant 2 because it's a negative value. And what value of cosine, or what angle value of cosine has a value of negative radical 2 over 2? Well, this one's going to be 3 pi over 4. Again, there should be no shame in looking back at the unit circle, but we just need to get our unit circle back in our head. So the inverse cosine of 1/2. We look at our unit circle. What angle value of cosine has a value of 1/2? The x value on our unit circle. Pi over 3. Now, back to sine. Arc sine of 0. Well, arc sine of 0, kind of following a pattern here. If you look at 3 and 6, it still is 0. Sine of what angle equals 0? Still 0. Down here in tangent. So problem number 10. Inverse tangent of negative radical 3 over 3. Remember, when we're looking at tangent, we're looking in quadrant 1 and quadrant 4. So negative, because it's negative the square root of 3 over 3, we're going to be in quadrant 4. And what value of tangent, what angle value of tangent has a value of negative radical 3 over 3? It's going to be negative 5 over 6. We need to stay within our range there, which is negative pi over 2 to positive pi over 2. So, same thing on problem number 11. The inverse tangent of negative 1, because 1 is negative, we're going to be in quadrant 4. And what's our angle value in quadrant 4? It's going to be negative pi over 4. And finally, with the cosine, the inverse cosine of negative 1/2, because because 1/2 is negative, we're going to look in quadrant 2. So we're looking at the x values in quadrant 2. And when we do, we see that this is going to be 2 pi over 3. Getting the unit circle back in your head, we only need quadrants 1, 2, and 4. We don't need quadrant 3. We never use quadrant 3 with our inverse functions. And I think I have a few more here on the back as you flip your paper over. So the inverse sine of negative radical 3 over 2. Well, again, radical 3 over 2 is negative, so we're going to be in the 4th quadrant. So what value of sine has a value of negative radical 3 over 2? Negative 5 over 3. And what value of tangent? What angle value of tangent has a value of radical 3? Remember, radical 3 was the answer previously. And then we had to fill in. Well, radical 3 was the answer that we're finding. We were given the angle. Now we're given the answer and we have to find the angle. So we're in the 1st quadrant. Radical 3. Pi over 3. Inverse sine. Remember, we could write it as arc sine, or we can write it as sine to the negative 1. But sine to the negative 1 of negative 1, better not say that too often. The inverse sine of negative 1 should be negative pi over 2. Again, for some of you who might be a little bit perplexed, looking back at the unit circle I think can help. Remember that on the unit circle, the cosines are the x values, the sines are the y's. We wrote tangent when we filled it in. So the inverse cosine of radical 2 over 2? Pi over 4. And the inverse tangent of radical 3 over 3, pi over 6. Radical 3 over 3 was the answer. We, early on in our trig unit, we had to say, well, tangent of pi over 6 equals what? So, tangent of what angle equals 1? And then to finish here, arc sine of radical 2 over 2. Pi over 4. We've got to get the unit circle back in our head. Inverse tangent of negative pi over 3. Well, if you look back here at 14, all that we have to do is change the sign. Because the tangent is going from negative pi over 2 to positive pi over 2. Sine is going from negative pi over 2 to positive pi over 2. And lastly, here in this section, the inverse cosine of negative radical 3 over 2. So we're going to be in the second quadrant. And when we look over there in the second quadrant, we're at 5 pi over 6. I know, I have a lot of examples there for a couple of reasons. One being that we haven't looked at this over a long weekend, so to speak. But as we finish here with the last three problems, what we're going to do is we're going to do a composition of functions. And thinking back to what the composition of functions was, and I would not write this on your paper, but we did something like f of g of x. So composite, more than one. And what we did is we figured out, well, what's the value inside the function? And we got an answer there, and then we took that answer and then we used it in the next function. So we're going to figure out what that inside value is, and then we're going to use it in the next value. So we're going to be going both directions when we calculate out these values. So starting on the inside, the inverse sine of radical 2 over 2, in fact, I think we just did it, or at least a similar one. Inverse sine of radical 2 over 2 we found to be pi over 4. And then, that's our answer for the inside function. Now we're going to apply it to our outside function. So what's the cosine of pi over 4? Well, it just happens that it's going to be radical 2 over 2. Number 23. Look at the inside function. That would be the farthest to the right, the arc cosine of negative radical 3 over 2. And if you're really paying attention, if you flip back and look at 21, I even wrote it as arc cosine negative radical 3 over 2. Well, what's the arc cosine of negative radical 3 over 2? It's 5 pi over 6. So we figured out that value farthest to the right, the inside function. And now what we're going to do is we're going to ask ourselves, well, what is the tangent of 5 pi over 6? It's going to be negative radical 3 over 3. So finally, here, we want to figure out what the inverse tangent of radical 3 is. And our inverse tangent of radical 3 is pi over 3. And we're going to use that back in our secant function. So we want to know what the secant of pi over 3 is. But remember, secant is a reciprocal function. In fact, it's a reciprocal function of cosine. So I'm going to write it as cosine of pi over 3 here for a minute. And the question is, well, what's the cosine of pi over 3? It's going to be 1/2. But remember, secant and cosine are reciprocal, so really when we find our answer here, our secant of pi over 3 is going to be the reciprocal of 1/2, which is 2. I'm going to circle that one just so that we know what the answer is.